it. Let me present. 1 second. There we go. I think you couldn't see it earlier. I was watching, trying to learn how to. Anybody know how to ride a bicycle backwards? You might need a special bike. I'm not sure.
Oh, hi. This is
really bored.
43,000, and today I'm going to be riding backwards. So if you don't know how to do that, it's when, I mean, obviously you don't know how to do it because you're watching this video. So you put your forward foot on the pedal, and then you sit down on the bars, and then you just push down, and then you get on, and then you're grooving. Shake and bang. I guess if you're having trouble, you get more stable the faster you go. So, I mean, you might not want to go too fast at first, but it helps with the not wobbly wobbling all over the place if you're going faster. So, and you definitely want to look behind you to make sure you don't run over any pedestrians or squirrels or apples.
Apples. All right. All right, guys. So today we're going to learn how to ride a bike backwards. But you need to know how to ride a bike forward first. Do you guys agree with that? So that's going to be our analogy today. So go ahead and, by the way, I didn't put this video for no reason. There's a reason for this. So go ahead and go to the pace, and I think it opens up for you automatically at 11. And open up the first Desmos link. And this was going to be a quick one, and then we'll do the backward bike riding. And go ahead and join that. I gotta do the teacher one, not that one. So you do the student one, and I'll do the teacher one. Is everybody okay if we do the same thing like yesterday with the Desmos instead of notes for today? All right. So I see one student is in. I'll wait for a minute for you guys to get in. There's only going to be like 5 screens on this one, and then we're going to do the other one. Okay, so it looks like 4 of you are in. 5. Good. Thank you. Nathan, Hayden, Isaiah, Hannah Van, Shiv, and Sophia. Good. All right. Let's see if anybody else is here to join us. Just take a peek. I see there's a few other people. Owen is here. Raven, Sophia. So while we're waiting for everybody, I just did a quick graph here, and go ahead and just give me the function of this one. Just like a little quick review of if you can do it backwards. What is the function of this graph? And go ahead and give me both forms if possible. And you could talk about it, and if you're stuck, definitely ask the class, ask me. Okay, good job. I see Hannah and Nathan are going for vertex form first, so Shiv. And good job, Hannah. And also, Hannah, do you see the steps? How many steps did it take to get from -8 to -6? So it went up by 2, right? So therefore, there's got to be a 2 in there somewhere. Okay. Good job. And Hannah says or, and Shiv says and. Do you think it's this equation and this equation, Shiv, or is it or this equation? Does that make sense? Can it be both at the same time, or is it one or the other? All right, good job. Nathan's got that one, and then Claudia has some weird word. I don't know what does that mean. I'll have to Google that. All right, good job. All right, Nathan's done. Good. Hayden's done, and okay. She's almost got his. Sophia's got her vertex one, and her factored one is almost done. Um, Van's got this down packed. He's got to get that second x-intercept. Perfect. Good work, everybody. Okay. I am very impressed. Okay. That you're able to see a graph and know what the equation looks like. My goal has been that you're able to see a function and imagine what it looks like, and uh, and backwards too, right? Good job. Isaiah was almost getting that one. Didn't take a peek at my screen. It shows everybody's work. Okay. All right. Hayden, take a peek over here. All right. And Owen's got this down packed too. Good work. Okay. All right, Hayden. Is there? I'm not sure if you're having any troubles typing that in, but let me know if I can help. All right. Let's go ahead and move to the second one. Okay. You can come back to us later, Hayden. All right. The second equation, you have to answer the question, select the answers that are available, and then sketch a quick graph. Okay. Let me see if I can. I forgot to write that in the instruction to say sketch a graph. So, I lost the train. Nathan, what's the question asking? I can't see what. Eric, no. What's the question asking? I can't even remember. Is it this one? I guess I can't see you guys' graphs. Does it let you graph, by the way? Yeah, okay. All right. All right. Good job. Everybody's picking the first one, and you're picking the second one. All right. So if it lets you graph, go ahead and just do a quick one. So just make sure to do your steps, right? You don't have to literally draw the steps, or you can if you would like. Okay. All right. Good job. And I wonder why I can't see everybody's graphs. I guess I have too much data. Oh, there we go. I see it now. Okay. And if you're on the first screen, go ahead and slide to the second screen right now so that you can be with everybody here. All right, so this one is what does the vertex form? Good job. Okay. Now this one you can't really draw very high up because you got to go up by 2, I believe. Let me see. Let me jump in on somebody's here and make sure we're going up by 2. All right, Sophia, I would suggest that on your graph, instead of you went up 1/1, you should be going up 2/1 because of that 2. That extra 2 in front of the 2 times. So it's not the 1 3 5 pattern. It's actually the 2 6 10 pattern. All right, so take a look at that one. And I think okay, good job, Nathan. You did go up 2/1. Good job. So you want to go 2/1, and you really can't do the next one because it's not going to allow you to go that far. All right, and then 0 and 2, the same thing. Oh, wait, never mind. You got that 2/1. And answer the question on the right side, Owen. What does it give you easily? I mean, this is the easy one. It's a vertex form. So go ahead and select vertex in the bottom too, like a little check mark. Make sense? Okay. All right. Now, like I said, I made this so that you don't have to draw a lot. Just all you're going to do is 3 points, basically. Okay. Very good. All right, let's move on to the next screen, number 3. And now we're going to go to factored form, and select which one it is, and then tell me which things it gives you easily, and then go ahead and sketch a graph of that. Good. You guys are. This is my robot mode. The robot is on the ground, which is the x-axis, and the robot can make holes in the ground, make them your x-intercepts. Now, just to help you guys out, -3 and 4 are 7 apart. Therefore, there's 3.5. Unfortunately, you're going to have to plug in -0.5, and I'll go ahead and give you that vertex for you. All right. And if you want, let me just go to decimals. I'll tell you what the vertex is so that you don't have to plug in -0.5. But if you did, you just basically do -2 times 3 minus 2.5, and then times 2.5. So it's going to be -12.5 is the vertex. So it's going to be way at the bottom. Okay. So go ahead and just do like a little sketch of that, even because you're not going to be able to go all the way to the bottom. All right. So just do like a fast sketch, because this one's going to be too hard to graph. But at least you got the x-intercepts, and oh, my mistake. It's actually positive. You guys are correct. This one's actually upside down. Okay. So I made a slight mistake, I think. This is an upside down one, so it should be in the top. Okay. So just go ahead and draw an upside down graph that kind of goes over 10. All right. And I should have made the graph larger. It looks like I only went to 10. Okay. All right. No worries. Okay. So you got the x-intercepts. Okay. No problem. Let's move on to the next screen. Okay. Because all I want is the x-intercepts. All right. This is the one I started to talk about yesterday. And then today we're going to look at it a little further. And then we're going to take a break for spring break. And then we'll come back to this in a week. All right. Which one of these 3 is standard form? Okay. And I gave you the same one. So there we go. Very good. And all I want you to do is give me that y-intercept. And that's pretty much all you can do. Next, I do want to plug in 1 into the equation. Let's get another point. So make all the x's become 1. So it's going to be 3 times 1 is 3. 3 minus 1 minus 4. What's 3 minus 1 minus 4? And go ahead and give me that coordinate. 3 minus 1 minus 4. That'll be 1 comma. What's 3 minus 1 minus 4? 3 minus 1 minus 4. There we go, Sophia, good job. So that second coordinate would be 1 comma -2. Now let's plug in 2. Okay, so it's going to be 3 times 2 squared. 2 squared is 4. So that's going to be 12. So it's going to be 12 minus 2 minus 4. What's 12 minus 2 minus 4? That'll be 6. Very good. Thank you, Oren. Okay. So 6 would be 2 comma 6. So you can start to see the pattern of this parabola, right? Now, I wouldn't want to plug in 3 because I know it's going to be going up. So I guess we could do -1. So it's going to be 3 plus 1 minus 4. 3 plus 1 minus 4. And what is 3 plus 1 minus 4? 3 plus 1 minus 0. 0. So that's going to be -1. Wait, I don't know if that makes sense. So let's see. If I plug in -1, 3 plus 1. Huh. That is weird. That is going to be -1 comma 0. I guess. All right. Anyway, we'll come back to that. So the idea here is you can start to see the shape of the parabola, right? You can kind of imagine it a little bit, okay? Actually, I'm going to type it in Desmos just to take a look at it. So it's 3x squared minus x minus 4. Actually, it is actually negative 1 comma 0. So go ahead and take a plot negative 1 comma 0. And the reason is the steps are super big. They're 3 times. And then you can kind of, you can see it's a very skinny looking parabola, right? We don't know where the vertex is yet, okay? But we know it's somewhere close to 0. Okay. All right, last one, all right? Let's go to the next screen. You see how the standard form is the hardest, all right? All right, this is the last one on this, topic. Go ahead and write the equation for this one. And go ahead and also write it in factored form and kind of estimate the x-intercepts. So do it in vertex form for sure, right? And by the way, how far did it go when it was at 3 at the top and then it went down to 2.5? So what was that first initial step? How tall was that initial step? Very good. Okay. Good job, Van. You're working on that vertex form. And don't forget to, once you're done typing the vertex, don't forget to check the initial step, the first step. How tall is that first step? Because you're going down the stairs from 3, and then you went down to 2.5. So the steps aren't size 1, they're smaller than that. And it's going down, right? I can see a lot of you are putting the decimal version, negative 0.5 in front. Very good, okay? Very good. Nathan got the factored one in case we're estimating that looks like about half, right, Nathan? It looks like it's right down the middle. Okay.
Sure.
Yeah, it looks like. I mean, it's kind of hard to tell, right? But right, kind of. All right. So as you guys can see, the standard form is the one that's kind of sucky, like right. And would you ever want to, let's say you had a function in factored form, would you want to turn it into standard form, which is harder to graph, or would you want to keep it in factored form? So let me, good job. Okay, I think you guys are almost done there. All right, let me take you to factored form. I think it's in the screen 4. All right, so look at, I'm going to take you all to screen 4. So look at the factored form one, the one in the middle. You could easily graph that, right? You could plug it in, you get the x-intercepts. Would you ever want to convert this to standard form and make it harder? No, you wouldn't want to make it harder. So today we're going to learn how to turn it into standard form. And you're like, well, why would I want to make it harder? Like, that makes no sense. Well, the reason you want to learn how to turn it into standard form is because in the future, you're going to get them in standard form and you're going to want to turn them into factored form. You're going to want to do them backwards, like my bicycle guy here.
Right, you're forward.
Right.
Down, and then you get on, and then you're grooving.
So you today we're going to turn factored form into standard form, and for the only reason is so that later on you know how to do it backwards from standard into factored. Okay, so that's the reason we're going to turn factored, which we like, into standard, which we don't like. And the only reason we're going to do that is so we can learn how to ride a bicycle forward so that we can learn later how to do it backwards, okay? All right, so go ahead and close this. I'm going to give you guys full credit for this. And then the second link, go ahead and go to the pace and open up Desmos 2. Let me put the link on it. It's not quite there yet. Let me create a class code. 1 second. One second, almost there. Okay, the link is there now. The second link, go ahead and open Desmos 2. And today we're going to turn factored form into standard form, which we don't really like standard form. But the goal is that you eventually you're going to know how to turn standard into factored. Okay. So we are going to, let me open up my screen too. Let me see where you guys are at. And I was kind of sharing Desmo stuff with my peers, and I started to say, hey, you guys can do this. It's pretty cool. You get to help students at the same time. So I made them this one for them to try out. So we'll see what happens. All right, so I did put a video for, let's go to this one real quick. We're going to come back to the video that Mr. Ash did for me. And let's go to number 2. All right, so I'm going to show you how to multiply without a calculator with an area model. And it's 17 times 14, okay? So what you do is you break apart 17 into 10 plus 7, and then 14 into 10 times 10 plus 4. Then you multiply 10 times 10, and then 10 times 7, and then go ahead and fill in the second box. All right, so this would be 40. Whoa, my handwriting is really horrible on this one. And the next box would be 28. So then add everything up. So what does the what do they add up to? What's 100 plus 70 plus 40 plus 28? And go ahead and type it in if you don't want to call it out. Okay.
It'll be 258.
Yeah, something like that, right? 100.
198.
So see, let's try. What you could do is you can write it here: 100 plus 110, right? Plus 28, and that's the same as 210, right? Plus 28. Kind of like break it apart little by little. So in is that 238? I believe.
238.
238. There we go. So go ahead and type it all out, like little by little. Now there's a reason why we're doing this, because we're going to turn everything into x's, but you'll see in a minute. All right, let me close this. How do I close this? Oh, I think I'm breaking you guys. Okay, so let's all move to this one. Go ahead and try this one out. What is 14 times 23? And go ahead and write it out on your screen. So you can do 14 is 10 plus 4. You could also do 20 minus 6. It still works. But it's actually easier just to have positives. And 20 is 20 plus 3. So go ahead and type everything in, and I'll take a peek and see how you guys are doing. Good. Okay. Good. All right. Good job. Good job, everybody. And notice how it doesn't matter if you put the 10 plus 4 on the top or on the side. It doesn't matter which way you do it, because you're going to multiply it, and you're doing area. It's called area model because you're making an area of things. So at the end, we're going to add everything up. So it's going to be 200 plus 110 plus 12. Okay. Sophia says it's 322. Shiv says it's 322. Devin says it's 322. Okay. So do you see what we're doing here? We are converting factored into standard. 12 times 3 are factors. They're factored. They're broken apart, and we're going to combine them. We're going to multiply them, and we're going to turn it into standard form. Okay. Good job. Claudia is getting that almost done. All right. And like I said, you could also do it. You can make it crazy. You can say 20 minus 6, 30 minus 7. You can make it, 14. You could put 7 plus 7, right? It doesn't have to be 10 plus 4. You could put 7 plus 7. You could put 9 plus 5. It doesn't matter how you break apart that 14. All right. So let's take a peek at how this works with factored form. Okay, so here is factored form. All right, let me see. So x minus 4 times x plus 2. That looks like factored form. Do you guys agree with that? So go ahead and do the same thing. Now, this time, you're not going to be able to combine x squared with anything, but the 2x and the negative 4x, you are going to be able to combine like terms. Okay, so the x squared will stay x squared, and then 2x minus 4x is negative 2, and then the negative 8. And Devin, be careful on that one. It's the last one is 2 times negative 4, so that bottom right corner should be negative 8. Good job catching that. Very good. And then go ahead and type your standard form on the right side. And what you can do is you can circle the two that you're going to be able to add together, which is basically the top corner and the bottom corner. The 2x minus 4x, you're going to be able to combine. Okay. Good. All right, and Amar, you can actually put your answer on the right side. You could type it in. Take a peek at my screen. See everybody over here. Okay. And then Devin, technically for this particular, there is not a function, so you wouldn't need the f of x. It's just an answer. Okay. So we're just basically multiplying two things. So technically, you wouldn't put f of x because it's like saying what's 2 times 3? It's 6. All right, so take a peek at my screening if you're stuck a little. A lot of people are catching up. And Sophia got the idea of circling the two that you can combine. That's exactly what Mr. Ash did on the video that I put in the very beginning. And that's exactly what I do usually. After times, I get lazy and I don't do the circle, but I know that those two corners, I can add them up. Okay. All right, good work. All right, and Devin, take a peek at my screen. You can see how people are doing. Okay. Hey guys, so this is learning how to ride your bicycle forward. Okay, we're taking factor form, which we like, and we're turning it into standard form, which we don't like.
I have a question.
Yeah.
So why is it always negative? So like x to the second minus 2x minus 8.
Well, for this particular case, let me jump in on Sophia's. Look at my screen. Well, if you added 2x minus 4x, this is a negative number, right? But let's pretend that the 4 was positive. Just pretend, and that 2 was negative, right? So then this would be negative 2x plus, so this would be 4 minus 2. Make sense? So it's not that it's always minus, it's just that it happens to be minus, in this case, 2. Okay? You agree with that? So sometimes the middle number is going to be positive, sometimes going to be negative.
Yeah, okay, cool.
Yeah.
Thank you. I was just curious.
Yeah. And also, the bottom number, the negative 8, that's always going to be negative if the two numbers are opposite signs. But if they're the same sign, if they're both negative, then that's going to make a positive 8. Or if they're both positive, well, it's going to be a positive 8. Good job. Okay. All right, guys, let's move on to the next screen and go ahead and do this one. And now this one, Amar, you're gonna actually see that there's probably not gonna be any negatives because look, there's nothing negative. Okay. So again, we're turning factored form. We're turning factored form into standard form. And like I said, probably 5 times already, the reason we're doing this because later on we're going to do it backwards. We're going to get standard form and we're going to do the same process we're doing here, but we're riding the bicycle backwards, which is harder to do. By the way, Isaiah, when we're doing this forward, where do you put the numbers? The outside numbers first or the inside numbers when you're setting it up? The numbers outside the square or the numbers inside the square? Isaiah, what are you doing first right now? I see you doing it. So are you doing the numbers outside or are you doing the numbers inside?
Inside.
Well, no, right now. So you're typing the x on the outside, correct? You're doing x plus 4. You're going to put them on the outside, right? And then x plus 5 on the outside, correct? When you're going to type them right now, do you get the answers for the inside the squares first, or do you have to write down the outside numbers first? Anybody? Do you put the numbers outside first or the numbers inside first? Inside the squares. What do you do first? Anybody?
Outside.
Outside. Good. So when we do this backwards, where are we going to put the numbers first? Later on. Inside, exactly. Later on, we're not going to know the outside numbers. We're going to know the inside numbers. And the inside numbers will tell us the outside numbers. See, little by little. All right. Like Isaiah, see how you do them in red? Later on, you're going to know the red numbers first. And you're not going to know the blue numbers on your case. Does that make sense? So, and trust me, when you do it backwards, it's a little harder, but I'll guide you through it. All right, little by little. Okay, I got this. I got your back. Okay. All right. So you guys turned x plus 4 times x plus 5. You turned that into standard form by saying it's x squared plus 9x plus 20. Okay. Very good. Okay. All right. Let's move on to screen 6. We only got a few of these, and then we'll be done. What about this one that it's 3x times x minus 4? So do you need all 4 boxes or you just need like a 1 by 2 box? Go ahead and try that out. Now, you know how to distribute this, but trust me.
Still in 5.
Yeah, exactly. Oh, you're still in 5? All right, here we go. Let me move you. Thank you. Appreciate that. So on this one, since the outside number is only 3x, you don't need a second box. So Hayden, it's actually 3x together. So, and in Hayden, there we go. So put 3x together. It's not 3 plus x, it's 3x. So basically, you're only going to need 2 of the boxes. Does that make sense? So you're going to need, there we go, okay? Good. Now, the reason I made this is so you can see that you don't need the bottom or the left. It depends how you do it, right? Sophia is using the left side. Devin's using the top side. And Devin, so 3x times x would actually be 3x squared. Make sense? And then Hannah too. When you're multiplying, it's actually going to be 3x times x is 3x squared. Careful. I've done that a lot of times too. And then the same way, when you do 3x times x, your brain wants to add them, but you're actually multiplying them. So it'd be 3x squared in the very first box. Good. And Claudia, don't forget to put squared on your inside of your 3x squared. When actually, Claudia, it's not 3 plus x, it's 3x. So put that x next to the 3 on the top. Make sense? So don't split up the 3x on your very top. Well, let's take a peek at my screen and you can see how I'm guiding people through that. There we go. Very good. Good job. Good job, Ann. Okay. All right, good. And then Hayden, the same thing. 3x times x. Our brain naturally wants to add them, but you want to actually multiply them, which would become 3x squared. Good. Good job. All right. So when you have it's called a monomial. A monomial is like 3x. That's just one thing. And then binomial is x minus 4, which are two separate things. Okay. When you guys take IM3, we're going to do the box will not be a 2x2. It'll be a 3x3, which would be a bigger box. But it's the same process. So you'll do fine. If you learn it here, when you take IM3 with me or Mr. Ash or anybody else, you'll remember this, even if you forget it temporarily. Good. And perfect. I think everybody's almost there. Good job. All right, Amar, fix that 3x squared. I don't know. It's not a big deal, but the square should be on the top, right? And it doesn't matter if you started with negative 12x plus 3x squared. It's perfectly fine. But
I tried to do that. It just wouldn't let me put it on the top for some reason.
Okay. And if you ever can, just put 3xx. So just put two x's next to each other. That's 3x squared. That's my sneaky way to do it too, right? Make sense? So put 3xx, right? That's 3x squared. All right, let's move to the next one. And then we're almost done, guys. So I'm only going to take you to, all right, here's a different one. And this one is what's it called? Binomial times binomial. So it's factored. Good job. Okay. Good. Perfect. Yeah. Very good. All right, and good. 2x squared plus 5x minus 12. Perfect. Good. All right, good. And Amar, on that one, you can join 8x and negative 3x. You can combine those, right? So your answer is perfectly correct, right? But since you have like terms, you can combine them. So 8x minus 3x, you can squeeze those together and become 5x. Make sense? Good job. Okay. All right, so we're converting from factored to standard. And actually, you wouldn't really want to convert from factored to standard because factored is like cool. Like you got the x-intercept, you can plug in numbers easy. You can get the y-intercept pretty easy, just multiplying. By the way, what is the y-intercept of this answer? I of this function if it was a function?
-12.
Negative 12. Which one's easier, the standard form or the factored one? Where is it easier to see negative 12, right? Obvious. That's an obvious question, right? Yeah. But look, can you just put 4 times negative 3?
Yeah.
I mean,
Still not very helpful.
that's pretty easy, right? Do you agree with that? It's like, it wouldn't be like very useful to turn this whole thing into standard mode just to get negative 12. When you can actually, you can just multiply those two, which is what you're doing in the bottom corner, negative 3 times 4. All right, guys, so we're almost done. Go ahead and type in your understanding right here. What just write down what you understand about converting. Now you come up with an example. Explain your understanding of how you. Oh yeah, that's right. So you come up with one, any factored one, and then explain. But come up with one first, Isaiah and Van. Like make one up. Okay, first make it up and then do it. Just you come up with something different. I want to see everybody have different stuff. Okay. Owen's going to go crazy and do 17 times 9. 17 times 9? Shoot, I don't know what that is. I know what 17 times 10 is. So then I guess that would reduce that answer 170 by 117. So it'd be 170 minus 17. Good. Good. And Nathan, yeah, those charts are called area models. If you want to adjust that, right, you can call it an area model. By the way, this is not the only way to multiply, to convert. This is not the way I learned it. I learned it a different way when I was a kid. But this one's really good. Like it's clear. Mine is faster, but I made a lot more mistakes. I would do this in my head, but I would make a lot more mistakes. Very good. Okay. Good. You're very good, Owen. It's good. This is like it's a process, right? It's little by little. And on yours, you would combine 153 plus 10. So Hayden picked the negative, right? Good job. Nathan picked some negative. Now, Claudia, I like your, see, it doesn't matter if you put 4x minus 2, if you do it like backwards, it doesn't matter. You're still going to be able to combine it. The only thing would be on Claudia and yours, it should be 12x squared. Check out on your area model. It's not 12, it's 12 times x times x. Make sense? There we go. Good. And then go ahead and circle the like terms, kind of like Sophia did up here. She picked my favorite color, purple. Circle the like terms. And then Devin, you should have a square somewhere. It's probably the, be careful. Negative x times 39x is negative 39x squared. So be careful not to add them, right? So in area model, you're multiplying. There we go. Good job. Okay. Good job.
What do you mean by like terms?
Well, like terms are like, for example, 5x and 6x. They both have 1x, so that you can add them, right? And 5x squared and 6x aren't like terms because one's an x squared and one's an x. When I taught middle school for 3 very long months, I used to say, think of it as like a family. X squares are like grandparents and X's are parents. And then if you don't have an X, like kids. So like Claudia's, you have negative 6x and 8x. Well, they're like parents, right? They're like each other. And then the X squares are like the grandparents, and then there's great grandparents, and so forth, right? So you can't combine grandparents with parents. They're not like terms. Anyway, it kind of worked for the middle school kids. They kind of got that idea. But yeah, that's what like term means. Good job, everybody. All right, so the last thing, and you're not going to do anything. You're just going to watch my screen. So go ahead and we're done with this. You got full points. I'm going to actually double up points on these kind of things to make them worth your time. But I want you to see me riding a bicycle backwards, but in a. So let me open up this. Okay, everybody looking at my screen? Okay. I am going to, figuratively speaking, right? I'm not literally going to ride a bicycle backwards. Figuratively speaking, this is what you're going to do when we come back. I think I made a video. Yeah, I made a video for my previous class. All right, watch this, guys. So this is the only thing you're going to do. Whoops, hang on. Technical difficulties. There we go. See if it has audio.
Hey everybody, here's how you turn standard into factor. So let's suppose you have a factor, let's do standard form. Let's suppose you got this.
That was me last year.
All right, so you have this function and you want to factor it. So you can find the x-intercepts really easy. So x squared comes from here.
See, I put it inside,
Bound
right?
stays there. So you automatically know that these are x and x. And then negative 36 is here. So these are fixed, they'll stay there. All right, so what you want to do is over here on this side, find all the numbers that multiply to negative 36. So multiply to negative 36. Then you start thinking, okay, we have, 36 and 1. We got 2 and 18. So then these two have to add up to negative 9. So check if they add up to negative 9. So 36 and 1, that's going to be 37 or 35. So that's not going to work. 18 and 2, well, that's either going to be 20 or negative 16. And these two, it's not going to work. You could do 6 times 6. And 6 plus 6 is 12 or 0 if you subtract them. That's not going to work. You can also do 9 times 4, that's 36. And if you add them, that's 13. Or if you subtract, that's 5. That's not going to work. Then you have 12 times 3. And then if you add those, you get 15. Or subtract, you get 9. And that's what we want. So therefore, this is going to be 12x, 3x. And it's negative. So this has to be negative. They have to match. So this has to be negative 9. Therefore, this is 12. This is 3.
All right. Anyway, that's where we're going, guys. See, I rode my bicycle backwards. Now, I picked a really hard one that had a lot of possibilities, right? When we start, I'm not going to give you this hard one, right? Because this one took a lot of tries. Anyway, so I did it backwards here, right? I rode my bicycle backwards. I started from the inside and went outside. And Claudia, what was the hard part of finding the like terms? Does that make sense?
Yeah, it makes sense.
Yeah, so yeah, the hard part was trying to figure out these two red numbers, right? The easy part was to get x and x. That was easy, right? And then I slid the 36 here because that 36 comes here. But there's a lot of numbers that multiply to become 36, right? But only two numbers will add up. Because remember, these two have to add up. These two red ones have to add up to negative 9. Anyway, this is where we're going. I wanted to show you this video only so you could see why we're turning it into standard form. Because later on, you're going to turn this. And by the way, what is the x-intercepts of my equation? What are the x-intercepts, everybody? Is it 3 and negative 12, or is it negative 3 and 12?
The last one.
Yeah, the last one, right? Make sense? Now, would you be able to know the x-intercepts by looking at this? Just by, no way. I can only find the y-intercept, okay? Anyway, that's all I have for you guys today. And this is just an intro so you can see me. This was me. This little video was me being this weird kid with his, what did he say? Shake and bake? I'm not sure what the shake and bake was. This was me
You're
grooving.
Shake and bake.
Okay, that was pretty funny. All right. Anyway, so that was me shaking and baking, turning the standard form into factor mode by doing it backwards. All right, guys, great job. Okay. Have a great break. Hopefully you don't have too much to catch up on, but if you do, go ahead and do that and I'll give you guys full points for any missing assignment or anything you don't have full points on. Okay.
Thank you, Mr. Quinones.
Bye bye. You too.
Bye, Mr. Quinones.
Bye, Claudia. Bye, Aiden. Bye, Brandon. Bye, Colin. Bye, everybody.